For the beam loaded as shown by double integration method, determine the deflection and slope under the point load and when the load is at the center of the beam. EI is constant. So first, let's compute for the reactions. So set moment B0, clockwise positive, so we have equals AY times L minus P times B. So AY equals PB over L. Then we establish moment equation at this section here so that it will be for the entire span. So EIY double prime equals moment at this section. So EIY double prime equals PB over L times X minus P times this distance is X minus A. So integrating EIY prime equals PB over L times X squared over 2. Then minus P over 2 times quantity X minus A squared plus constant of integration C sub 1. Integrating further, EIY equals PB over 6L X cube minus P over 6X minus A cube plus C sub 1X. There's no C sub 2 because the deflection at A is 0 when X is 0, so it's a waste of time if we put C sub 2 here. Anyway, when we evaluate C sub 2 after setting up the boundary conditions, it will still be 0. Remember the interpretation in the derivation of the double integration method. So when X is L, deflection at B is 0. So 0 equals PB over 6L times L cube minus P over 6 times L minus A cube plus C sub 1 times L. Solving for C sub 1, transpose this to the left, so it is P over 6L times L minus A cube minus PBL over 6 after we divide by L. Then take note that L minus A is B. So C sub 1 is P over 6L B cube minus PBL over 6, factoring out PB over 6L, and we'll have B square minus L square. Factoring out further, B square minus L square into PB over 6L times B minus L, B plus L. And take note that B minus L is negative A from the figure. So C sub 1 is negative PAB over 6L times L plus B. And this C sub 1 divided by EI, because when X is 0, this is 0, this term is 0, this is ignored because the value inside the parentheses is negative. Remember the principle in double integration method. So it will leave C sub 1 when X is 0. So C sub 1 therefore is the slope at A. So divided by EI, so theta A is negative PAB over 6EIL times L plus B. That's the value of theta A. Then for theta under the load, we set X equals A in this equation here. So AI theta equals PB over 2L times A squared. This is 0 when X is A. Then plus C sub 1, which is negative PAB over 6L here times L plus B. So let's expand AI theta equals PA squared B over 2L minus PAB over 6. Distribute, then minus PA B squared over 6L. Factoring out PAB over 6L, then we'll have 3A minus L minus B. Replacing A by L minus B. So A theta equals PAB over 6L, quantity 3 times L minus B minus L minus B. So 3L minus L is 2L in these brackets. And negative 3B minus B is 4B. So EI theta is PAB over 6L, quantity 2L minus 4B. Then factor out 2. So EI theta is PAB over 3L, quantity L minus 2B. Finally, data is under the load is PAB over 3AIL quantity L minus 2B. So this will be the value of data under the load P. Then for the deflection under the load P, we use this equation and set X is A. So AI delta equals PB over 6L A cube. This is 0. Then plus C sub 1 negative PAB over 6L L plus B times X, which is A. So distribute and simplify. So AI delta equals PA cube B over 6L minus PA square B over 6, then minus PA square B square over 6L after we distribute and simplify. So factor out PA square B over 6L, then we have A minus L minus B. And we take note that A minus L is negative B, so AI delta equals PA square B over 6L, quantity negative B minus B, and negative B minus B is negative 2B. So the AI delta equals negative PA square B square over 3L. So that's the deflection under the load, negative PA square B square over 3L, then divide by EI, so 3AIL. Then when the load P is at the center, that means A is L over 2 and B is L over 2. Substitute here and we will call it delta M, the maximum deflection. Of course, when the load P is at the center, the slope would be 0 because by symmetry. So the slope would be 0. It will not be shown anymore. Although we can verify that it is 0 when B is L over 2 here. This becomes L minus 2 times L over 2. So this is 0. That's why theta is 0 when the load P is at the center. So we'll just derive the maximum deflection. And we expect that it is negative PL cube over 48 EI. After we substitute A is L over 2 and B is L over 2. So AI delta M equals negative PL over 2 square, L over 2 square over 3L. So this is 1/4, 1/4. So 1 over 16. 16 times 3 is 48. Therefore, it is delta M equals negative PL cube, L to the 4 divided by L, so L cube over 48 EI as expected. So delta M equals negative PL cube over 48 EI. So that's it for this problem. I want you to familiar with this formula and this formula only. For the rest, you just derive by integration or by any method.